Welcome everybody. So we'll go through today step by step how we can create a Vellum simulation where a big ball will go through these small balls and make them stick on its surface while it is rolling. Okay, so let's go through the setup, easy and simple setup. So we will start with geometry. Let's create a sphere. Ctrl G. Let's make it bigger. Move it up in y-axis. X. And here we'll create a small grid. Let's visualize it and make it in the front of this subject. Somewhere here, make it smaller. Okay, create copy to point. Here I will modify or create attribute for the P scale. So P scale, let's make it tiny. Good. Let's increase the column, something like this. Okay. Now for the big ball, create a ball velocity, and we will move in X. So just give it 20. We'll create RBD solver. Let's watch. Okay. So somewhere here, move the grid. So as you can see, it is rolling. Very good. Now from the points, we'll create the Vellum strut soft body. And the cloth is strong. We'll also make the bending strong. The strut itself, we make it strong, and the triangle point, make it 2 and increase the radiation. So if you view it, we'll have plenty of constraint inside it. Now, Vellum solver. And for the big ball, let's give it a color. Let's go with something blue. And the small balls, the small balls will give it a color of something of white, pinkish. Right. Okay. I will connect here the collision geometry, and here let's just have a look. The outcome from now. Still move to other constraint, merge it. You can see both. Where is it up? Okay, let's try again and see. It is like squeezing them. Okay, so to make the interaction, you need to go inside the Vellum solver. Here we'll create a Vellum constraint. I'll do something before that up. Let's create groups. So here we have a group, here we have a group. This we'll call big, this we'll call small. It's always better to have groups. So we go inside net, or we can use the J will connect also here. What we want glue. When we want it, each frame. Which group? Small. Where we want it? Yeah, it's not two. I was checking, should be attached to geometry here. Yeah, so which group? Small. Where we want it to go? We want it to the target up. This one, Control C, target path, Control V. Now it's big. How much we want? Let's see. Zero. No, why it's happening like this? Because see, there is like a distance, a vector. So we go inside the Vellum, and in the maximum distance, let's make it 0. Have a look now. Just raise it. See it going down. Okay. So that means the strength is not enough. We need to increase its stiffness. Let's reset. So one thing is missing. Oh, maximum distance. Let's make it with a small value. Check again. Yeah, with 0 it will not be considered. So, or maybe because it's at the center of the point, it won't be seen. So it's working now. Let's make it 30 frame. Okay, I want to make it narrower. This wide by 2. Very cool. Now what I'm going to do is delete this one, and here we'll create a Vellum, or what we call it, part cache. The import. Make it explicit. Here I'll take it to another geo. Here small. Okay. What we want to do, we will cache it, and we want to experiment and start to play with the sliding grid. This one. Okay, so here we will go to task, create new schedule. Here we'll create a wedge. And the wedge we will try 5 different. We need one attribute. We'll call it slide, and it is a value list. It's a float, as you can see. So 1, 2, 3, 4, 5. We want very tiny. Here we want 1. Let's try 2. 1.5. 0.225. Here very small. Okay, so we go here. The sliding we put add slide. So this is a global variable. Here let's generate. So we have these. What else you can play with? The stiffness also. Wedge. We'll do 3. We'll call it stiffness. I don't want 5. Let's make it 3. We'll cut this one and this one. See here, stiffness I want 3, and the range for this one we'll make it 1. Make it a value list. 1, 2, 3. Here we'll make 1 million. 1, 2, 3. 1, 2, 3. Here 100. 1, 2, 3. Here we'll make it 1000. So the stiffness, we put at stiffness. So let's click again, generate. Total of 9. So raw geometry or geometry raw. What we can do, fetch. Let's go up here, and we want the V. Let's render. Make sure that we load, and here in the file we need to add here to backtick, add wedge index dot. So it will change accordingly. It's generate. We will have 9. After that, if we want to render, I think it's enough. Let's see what we'll come up with. Dirty and complex node. Oh, let's stop it because we need to make it animation. And task the python. Here it is a frame range, and here it should be frame by frame range, and here I will increase equal but 1, and frame per batch, all frame in one batch, because this is animation. Dirty and cook. We'll come back shortly. So it's going with these 9, because we have 9 simulation. It's going together, as you can see, all of them. So now it's complete from geometry. So let's choose this one, or this one, or this one. Good. So to view it, you just go here, the task. So already here I will write read. So we want to simulate it here, the object I'll add grid. This grid will make it big. Now I want my camera to be somewhere here. So we can examine. Like this. Okay, we'll add what is REDSHIFT? A dome light. We will choose one of the on the texture, HDRI. We choose one, right one. Let's go with this one. And we'll create tool material, hit shift, this one will be called big, and here we want the point attribute, the CD, go to the color, and don't want that much reflection. Let's copy. We call this one small. So for the small, we add it here, and for the big, we add it here, and we need another background. This one we'll wait for this, and we'll make it darker, roughness, very little, so the grid. So in the out, let's go to out, here we create a REDSHIFT, drop, we have the camera set, and make it low. Also make sure here unblocking, exactly make it as a permanent. And what else in the output? I don't want render to unblur. And here I will add dot edge index. We copy it and add it here also. And I want it to be JPEG, GPG. Let's have a look. Let's look at one of the frames. Let's modify it, rotate, so maybe I can play with the material. That's all. I want no reflection. Maybe the color also. Let's modify the color. Also the lighting, make it the light. Different That's good. Now save. Let's go back to the task, and here we go to the out. So here I want to render all of it. We'll do a raw fetch, and we want to fetch this one. Here we want the frame range, and here all in single patch. Also we need another schedule. This one REDSHIFT, because we want to make it as a single. So the schedule, we add it here. Here we want it as a single. Let's generate 270. So 270 frame. I want to make it, where is the camera? View. Okay, that's enough. After that I want to add overlay. In the overlay I want these two parameters, the slide so the amount is the other one is the stiffness. Is so we can evaluate here. Generate, so 270. Now I want to by frame, partition by frame. So each similar frame will be together. We'll go back to 9, 30. After that we want to do montage. No, magic we call it. Magic. In the magic we want a JPG. Let's steal this one. Here I will add it. Overlay. Let's call it overlay. Magic. Okay. After that we will wait for all to gather them all. So 30. And here we will do the video, and in the video this one we need to change. Generate. Okay, let's test now. Because here we save it as a read. Now here it will start to render one by one. So we'll come back when it's done. So you can view all of them. Total of 9. As you can see here, we have 9. Finish the whole render. These are the files. I had some issue with the spheres here, so I just remove the color, maybe artifact. We'll check it, we'll have a look later. Now here I'll just choose read file. Let's see what we have here. Automatic and dirty and cook. Now it finished the overlay. As you can see here, the slide and the stiffness is showing. Now it's creating the magic, and now the video. So each frame will be like this, showing each variance. And the video is done now. This is the slides. This is when it's high. So see, it's flipping. And this is when it's 0.5. And this is when the stiffness is weak. 1,000, 100,000. This is 1 million. So this is the more stable one. This one. So thank you very much for watching.